Alrighty, welcome back everybody. Starting the afternoon of day one of Vulkanized. To begin with, we're going to start with Richard Wright at LunarG, who's going to talk about Vulkan development for Apple desktops and devices.
Thanks. So I'm the first speaker after lunch. I hope I can keep you awake. If I can't keep me awake, we're going to be in big trouble. So yes, I work for LunarG. I'm on the Vulkan SDK team. The Vulkan Apple SDK is my responsibility. So if you like it, you're welcome. If you don't like it, you need any help at all, my name is Charles, and I can help you with that anytime you want. So how many of you are already Apple developers? Vulkan or not, OpenGL, somebody's game engine, you're doing stuff on Apple. Okay, so good. How many of you are interested in moving to Apple? Okay, good. All right, well, maybe I can change your minds. We'll see. So what we're going to talk about, what's the deal? No native driver on Vulkan. We'll talk a little bit about Molten VK. Bill's going to follow up after me to go into more of a deep dive on Molten VK. And I'm going to talk about how to use Molten VK to ship your Vulkan applications on Apple desktops and platforms, and about Vulkan validation layers. Basically, how is Vulkan different on Apple, if at all? Just a few things. Hopefully, pretty much I'm going to cover everything you need to know. Maybe not in great deep depth, but I'll give you a good overview of everything you need to know to do Vulkan on Apple. In the past, Apple worked with IHVs to produce low-level drivers. And when I came along, the low-level driver on Apple was OpenGL. And OpenGL was everything. The whole shell, the desktop, everything was OpenGL, and your OpenGL stuff would get composited with it. Apple's moved on, and now they have Metal. Metal is the low-level API, and everything on Apple is Metal, and Metal is all that's there, period. End of discussion. If you want to use OpenGL on Apple, you still can. Apple still, I'm not sure how much longer they're going to do it, but they ship OpenGL built on top of Metal, and it runs, it runs well enough. It's much like Angle. Angle is another layered implementation. It's OpenGL on top of Metal. Anecdotally, by the way, the Angle implementation of OpenGL is actually quite a bit faster than Apple's. So if you're still doing OpenGL on Apple, and you don't want to go to Vulkan, but you need some more performance, I would recommend you look at Angle. I'll give them a free plug. They're doing a good job over there. It's also a good example of how a layered implementation can be really good or can really not be very good. And the difference between a really good layered implementation and a really bad layered implementation is not that it's a layered implementation. It's all in how the implementation is implemented. Did I just say that? I did. So Metal is a nice thin API, kind of like Vulkan. It's fair to say Metal is a little higher level than Vulkan. I've heard it described as Vulkan with smarter, defaults. You don't have to. It's kind of like when you have children. Don't jump on the bed with your shoes on. Don't jump on the bed with your shoes off. Don't jump on the bed with your socks on. Don't jump on the bed with one sock on, but the other one off. Don't jump on the bed with the other sock. Sometimes, let's be honest, Vulkan can be kind of like that. You have to be very explicit. Anyway, I'm getting off topic because I ate too much at lunch. Where were we? So, simple solution. Let's put Molten VK on top of Metal, and that's what Bill Hollings did with let's put Apple. We're going to get this right. Let's put Vulkan on top of Metal. And that's what Molten VK is doing for you. You do not have to learn Metal to do this. I see this all the time on social media. Well, I've learned Vulkan, and I don't want to do Metal. I don't want to move to the Mac because why? I got to learn Metal and Vulkan. You don't have to do any Metal at all. There is a little flag that says something about Metal you have to set, when you're creating a surface. But that's it. Vulkan is just Vulkan on Apple. It just happens to be, Molten VK is just simply the ICD for you. So your app is going to call Vulkan. It's not going to call Metal. It's not going to call Molten VK. It just calls Vulkan API stuff, and that eventually gets to the driver, whether you're on Mac OS or Windows or Linux or iPhone or Android or anything else. You're just writing Vulkan code. It's, quote unquote, that simple. Where do you get this magic library that makes it all so easy? The Vulkan SDK, which is available for free at vulkan.lunarg.com. There is a GitHub repo for Molten VK. It's open source. You can get it and build it yourself if you like doing things that way. If you find a bug and you become a Molten VK expert, we would love to hear from, get your pull requests and fixes and enhancements in there as well. So we have a couple of different ways that we package Molten VK. Some of these are good ideas and some of these used to be a good idea and are becoming less of a good idea, and I'll go into a little more detail about each of them. First is the system-wide ICD, kind of the way we're used to developing on Windows and Linux. You can install Molten VK in a system-wide location, and it's just there. Your applications can always find it. This is a great development environment. You do not want to ship your applications this way. End users should not have to install a Vulkan SDK to run Vulkan apps on Mac OS. But it is really nice because it seamlessly works with VK config. It seamlessly works with the validation layers. These are all things end users aren't going to be, exposed to, but they're really great things for the developer to not have to think about. Just install the SDK and everything is set up and ready to go. Molten VK is also a dynamic library that you can just simply plug into your bundle, and it goes in the frameworks folder, and you can link straight to it. Actually, yeah. No, I'm sorry, skip one. You can put the loader and Molten VK in the application bundle. The loader, of course, load Molten VK as if it were an ICD, but you can also link directly to Molten VK and use it that way, or you can link to it statically as well. Now, it's sort of like Republicans and Democrats as to whether or not you should statically link libraries. There are actually good reasons to statically link. There are actually not so good reasons. Whatever your reasons are, they're your reasons in your application's domain. But one of the primary motivations for linking straight to Molten VK in the past has been getting to some. If you are an Apple developer, you might want some of that metal magic mojo in your game or in your application. Maybe you're interacting with some Apple frameworks, you're doing something with the Apple Video framework or something cool with the Apple, acceleration frameworks, and it needs a metal texture and you're doing Vulkan. Well, there is actually I'll just pass it up. There's a metal objects extension, I'll get to that in a minute, that allows you to do that back and forth. And it's a regular Vulkan extension. You do not have to link directly to Molten VK. You do not have to call any private APIs. So now really Molten VK is a much better citizen of the Vulkan community, and that you can still have access to some vendor specific features without having to do any vendor specific gymnastics. You can just use the regular Vulkan extension mechanism. So the first of these options, installing the system-wide loader and ICD, the Vulkan SDK will do that for you. It's the top check mark. Install global installation, puts it in user local lib for you, and then your applications will just see it, puts the validation layers where they need to go, and you're good to go. Vulkan Configurator just works. I was actually hired at LunarG originally to work on a very old version of Vulkan Configurator before Christoph took it over. This is a really great tool. I leave it running all the time when I'm doing Vulkan on the Apple to get validation errors in my code. Yes, I do make validation errors in my code. This is great for finding bugs you know about and bugs you don't know about. And if you've been developing for more than a minute, you know what I'm talking about. Just because your code works doesn't mean it's correct. Just because it runs on your machine doesn't mean it will run anywhere else. And the Vulkan Configurator is a really nice sanity check. To automatically select, say, the Khronos validation layer, or use the profiles. It also finds bugs you don't know about. Sorry, my animations are not here. I'm used to that. It also finds, bugs you know about and bugs you don't know about. Let me just go on. So we do have layers on Mac OS and iOS. The most useful is the Khronos validation layer. We do not currently have, as been mentioned earlier, debug printf and GPU AV. We have some We have some really smart people at LunarG when it comes to shader technologies. I'm not one of them. I looked at it and went, well, that should just work, especially they added some non-semantic extension. And I'm like, well, I bet it turns on now. It did not turn on. This is probably going to be more important in the future because more and more of the validation is being done on the GPU. So this is an area that is going to be getting some attention. If this is really important to you, put it in that Vulkan developer survey that we were talking about, that all of us are talking about at the end of our presentation. I'm going to kind of skip down to profiles, API dump, screenshot. These are also diagnostic developer layers that are really useful during development. Graphics reconstruct is coming soon for the Apple. It will not be in the next SDK. I would probably bet a little bit on my reputation that it'll be out before the end of the year. So sometime in between there, we'll have graphics reconstruct. It is working in the labs, so to speak. But all of you know what that's like. Once it works on your machine, you're still a long way from shipping it. But it is coming along, and I expect that'll be cool. So last but not least, I go back up to shader objects and the synchronization 2. These two layers are emulation layers, and you may actually want to ship your application with these layers. You wouldn't ship your application with the Khronos validation layer unless you're a disgruntled employee and you want your application to run really slow on purpose and your manager to not be able to figure out why. But shader objects is a really useful extension. Everybody's not quite got on board and implemented it in hardware. This is available on all platforms, by the way, and it's also available on Mac. Same for synchronization 2. We actually have synchronization 2 now. I shouldn't say we, Bill has synchronization 2 now in Molten VK. But there is something to be said for having the same code path on all platforms, and so we've lofted in the SDK so that you can do that. And of course, you would ship these layers with your game or application. What does this look like on macOS? As has been mentioned earlier, Apple does not encourage system-wide libraries for you to install, so we put everything in an application bundle. Those of you who are not Mac developers, all a bundle is a special directory with a .app extension on the name of directory. And you ship the entire application bundle, and it has these other folders inside. Frameworks is where you put all of your executable dynamic libraries. There's also a plugins folder, and you can't put executable code like in the resources folder. Resources is where you're going to store, you put your database or shaders or scripts or things like that. Nothing that's binary executable. They have to go in a special way. So Apple really locks things down quite well on macOS and on iOS as well. But this is what it looks like. Frameworks is going to have your Vulkan loader and Molten VK, the ICD, and on most systems like Linux, you've got a Vulkan folder and ICD.d and explicit layer.d. Charles was showing you some of that earlier. We just stick that right in the application bundle, and the loader knows that it's on a Mac. Excuse me. And so it's going to look for these JSON files to point to where the ICD is. You might think, well, you know, why bother? We may have other ICDs beside Molten VK. Swift Shader comes to mind, you know, for non-gaming applications. On iOS, it looks a little bit different. Bundles are a little more shallow. But again, the same thing during development, when you want to use the validation layers or any of the other diagnostic or testing layers, you put those in the frameworks folder. And then the Vulkan folder, there is no resources folder. They just throw everything into the main app bundle. And that's where those JSON files go there. This is for development only. It's really useful. We've been shipping this for almost a month now. It came out in the SDK last month. And it's great for testing and development, but you can't ship an application this way. So if you want to ship with Sync2 or shader objects, Apple will not let you put naked dynamic libraries on the iOS App Store. You can get away with it on the macOS App Store, but they won't let you do that on macOS. So other ways people do this include the dynamic library. So you just put it in framework and link directly to Molten VK. Molten VK has all the same entry points that the loader does. So your code doesn't actually know any different. You either link to the loader or you link to Molten VK. It's the same on your side. But the hindrance is if you link directly to Molten VK, you do not get to use any of the layers. None of the layers will be detected or will work. This works everywhere. You can't ship applications like this on iOS. I think this is probably one of the two most common ways people have been shipping Molten VK in their games. And primarily, again, was because if you wanted to share objects between Vulkan and Metal, you had to call some private Molten VK API functions. You don't have to do that anymore. We have the Metal Objects extension, which is a really nice extension, worked very hard on by Bill and others. And that gives you all the capabilities that you need to, let's be honest, if you're shipping on Apple, you've all seen things, that some cross-platform things that are like the most generic thing possible, so it'll run everywhere. But if you're building for Apple, you might want to incorporate some Apple best practices or some Apple, features in your application so that Apple users don't go, what is this thing that you've done here? So this is a great way to have a nice portable code base written in Vulkan, but be able to integrate that with some low-level Apple APIs to give your end users, the best experience on Apple platforms. The other probably, this might be the most common way to ship in the past, was statically linking. There are a lot of advantages to statically linking libraries. So some people, prefer that anyway. You don't need to statically link if you, again, we have the Metal Objects extension if you want. There's an XC framework that ships with the Vulkan SDK. And that has static libraries for all three platforms, the desktop, iOS, and tvOS. One great option about this, actually two kind of nice options about this, it is valid on all app stores, so you can ship on iOS by linking directly to, to Molten VK. You could do development with the loader, use the validation layers, and then, before you go to QA, link to the static version of Molten VK, and that's a perfectly good way to do it. I think the best reason to use static linking on Mac is for making command line programs that you want to distribute to end users. Developers, if you install, the system-wide Molten VK and the system-wide loader, you can write command line programs and they work great. But you want to send this command line program to someone else, or you want to post it on your website or something like that. Command line program that has everything compiled into it, and it'll have, Molten VK just compiled straight in it. And so that's a valid use case for some cases as well. Maybe you're doing some compute with Vulkan, and you don't even need graphics, so there's no app bundle that you want to use. Okay, so that's sort of the overview of linking and packaging, which is like, your crash course in shipping an application on Apple. How is that different from Windows or Linux? What about the code? What do we got to do for all this portability stuff we talked about? The two extensions that we care about are the portability enumeration extension and the portability subset. So I'll talk about the first one first, obviously, the portability enumeration. The purpose of this initially was there's a story that, lots of games are using, let's say, our friends from NVIDIA. You've got an NVIDIA graphics card and you've got a really great NVIDIA Vulkan driver and life is good. But somebody downloaded this game off of someplace, whatever, and they had kind of a custom Vulkan driver that they did. And they colored a little bit outside the lines, and maybe they built it on top of DirectX or something themselves. And it wasn't a very good driver. And everybody who had a game who had been running on their nice NVIDIA driver on that platform, suddenly their game is crashing all over the place. Because there's a great mechanism when you create the in Vulkan, when you create the instance, you can enumerate the devices, you can look at the devices, and you say, what are the capabilities of all the devices and which one best matches my needs? But we all know 99 out of 100 of you pick the first device you see. You just go, enumerate devices. Is the number greater than 0? Yes, take the first one. And they would get the first device they saw, and it was not necessarily a good user experience. And now you've got all kinds of tech support problems and so forth. So they're like, hey, you know what? If you're going to make your own layered, I mean, this doesn't exist because of Apple. It actually existed because of a larger concern. If you're going to make a layered Vulkan implementation, you should say, hey, I'm a layered implementation. And you need to give games the option to opt out of a layered implementation, because a layered implementation may have holes in it. It may not be fully conformant. And we don't want old apps who are expecting, when they see a Vulkan device and expecting to get a fully conformant Vulkan implementation, to be getting this implementation that may have features that are missing. So we want new games, new applications to be able to opt in, look at the list of things that are available, and work around them if they want. But we don't want old applications who just pick the first device they see to find a non-conformant implementation. And that was the original motivation behind this extension. So it is an instance extension. So before you create the instance, I'm sure most of you have gone through some Vulkan tutorial or another. And first thing you do, give me a list of all the instance extensions. You look at them, you see which ones do I want. You add them to a list, and then you create your instance. And this is KHR portability enumeration. If this extension is there, it means you have a newish loader, and you can go, hey, I really don't want a portability implementation. You're not going to do that on the Mac. This is a talk about the Mac, because right now, a portability implementation is all you have. But on Windows or Linux, if you don't enable this extension and there are multiple implementations available, you won't see any of the portability extensions. You will only see the fully conformant, hopefully fully conformant, not like anybody would ever install a non-fully conformant Vulkan driver, right? That's a few giggles out there. But we are kind of expecting people to play by the rules here. So you add that, and there is this flag, create instance, enumerate. I'm a little tongue-tied, if you can tell. Create instance, enumerate portability bit. I'm actually still sick from flying yesterday. I think the plane flew upside down, landing in San Jose. If you don't get that, you will get incompatible driver on Apple devices. Just to get on a soapbox, whenever we release the Vulkan SDK, there's this document. It's called Release Notes. And for a year, we said, hey, you need to do this, and we're going to start enforcing it. Really, you've seen the parents in the drugstore, right? If you don't be good, I'm not going to get you an ice cream. And then they walk out with an ice cream and a screaming kid. If you don't do this, we're going to turn it off. A year and a half ago, we turned it off. All these messages. The SDK is broken. Molten VK is broken. What did you all do? We enforced this rule that we've been saying for a long time that we're going to enforce. So check the release notes. All right, that's my axe to grind today. So as I said a minute ago, I'll just kind of repeat. If multiple drivers are found and one's portable and you don't enable this extension, you will not see the portable driver. Maybe one day we'll have a fully non-layered Vulkan implementation on Apple, but I doubt I will live long enough to see that. But this is also important for you non-Apple developers. Microsoft is doing DirectX on top of Vulkan. Sorry, is doing Vulkan on top of DirectX. There is somebody else doing DirectX on top of Vulkan too. There's a lot of layered implementations. And as I said before, being a layered implementation is not a harbinger of poor performance. It depends on how good, a job they did layering that. I mean, we all do layers in our applications in our games, right? It's okay to have a layered implementation. You're likely to see this on Windows and Linux before you're going to see it on Apple, where we have multiple hardware implementations. But you never know. I can have hope. What does this look like in code? Typical boilerplate C++ code. You give me how many extensions do you have? Give me the list of the extensions. And then, something, you loop through the extensions and look for the one you want. Set a bool. Maybe you set a bit flag, or you've got something more elegant using C++35. But bools are nice and cheap and cheerful. So we'll add that to our list. Make sure I know I want the portability flag set, and then later on I'll set the flag. Maybe you just weave this into the code too, but make sure you do that. Right now, this is actually the only instance flag in existence. Don't count on that. So do a little, or don't you dare assign it, assuming it's the only one. But there may be more flags in the future. If you don't do this and you're on the Mac and you're newer than 1.3216, that was June of 2 years ago. So it's been almost 2 years. So a little over a year and a half. This has been enforced in the loader. You'll get error incompatible driver, and then you'll be posting on Lunar Exchange that the SDK is broken and the SDK is not broken. I'll just leave that there. All right, so that covers just a little bit of when I set up my instance, what do I need to do to make sure that my code is portable between Apple and other platforms. I have a layered implementation, aka Molten VK. Now what? So that's what this other extension is for, the portability subset. The portability subset. If you have a layered implementation, it may be a fully conformant layer. I think dozen is. I wouldn't bet. Yeah, we don't know for sure. A dozen may be a fully conformant Vulkan implementation. No, okay, I see some heads. Like, yeah, okay. Yeah, never mind. But there may be holes in it. And so the portability subset is an attempt to say, I want to query what holes are available and which ones are not. And honestly, it can vary between whether you have an old Intel Mac or an old Intel Mac with NVIDIA or an old Intel Mac with AMD or maybe Apple Silicon. So you really can't be sure. It's just like assuming I'm on Windows, everybody on Windows is the same, right? It's not, yeah. So just because you're on Mac OS, everything is not necessarily the same. So you want to look at this and make sure it has capabilities that you want to use. By the way, this is a provisional extension, and I think it might actually be on hospice at the moment. There is a new portability subset metal coming soon. I'll let Bill speak to that. He knows more about it than I do. We're probably not going to get rid of this because we don't want to break everybody's code. So I think it may hang around for a while, but portability subset metal is going to be the new hotness in that range. This is wow, I'm editing on the fly. This is a device extension. So, when you enumerate your device extension properties, this is the extension you're going to look for, and you're going to add it to your list of extensions that you want. I think Charles is going to talk about this tomorrow. Don't turn on every extension you see. It's like turning on every light in your house. Only enable the ones that you need. Again, sort of boilerplate code. Do I want to add text? No. Boilerplate code here. Get how many extensions there are. Get the list of them, and then like we do, loop through all the device extensions and see what they have that we want to use. And this is one that you want to use on the Mac. So if you see it, add it to the list, and you're off to the races. The way this works, it rides on the back of get physical device features too. So we already have a mechanism in Vulkan to say, hey, what do you have? Everybody's Vulkan implementation doesn't have wide lines or big points or anisotropic filtering. Technically, I think they probably do, but they might not. So we already have a way in Vulkan to query to see, tell me about your implementation so that I can adjust my code. I might decide I can't run on your, on your computer at all or on this device at all, but I might be able to, work around these limitations. So this extension just sort of rides on the back of that. We use the pnext pointer of that structure, which is a typical way a lot of Vulkan extensions work. We call it get physical device features too with that pointer set, and it returns and it tells us what we want to look at. This is what the extension looks like today. These are values on my old now M1 Mac. It was so new and amazing when I got it. Now it's getting old. 0 means the feature is not present, and these are subject to change. A really good example of that is triangle fans. So at the time I first made this slide, this is a brand new presentation. I'm not recycling a presentation, but it is a recycled slide. When the first time I made this slide, triangle fans were not supported on Molten VK. And now this pops up and says, yeah, I have triangle fans. So I'm going to pick on triangle fans a little bit because it makes a good example. I'm not really picking on it. But let's say your game needs triangle fans, and you see that I don't have triangle fans. So what are you going to do? Well, you can either go, well, that's it. I don't care about millions of Mac users. They don't have any money anyway. Once they bought their hardware, they can't afford games. Not likely. Not likely are you going to do that. So you might go, well, okay, I don't have triangle fans. I guess I'll use, there's lots of ways to get around not having triangle fans. Later on, suddenly triangle fans are on. But as a savvy developer, you might go, wonder what happened. And triangle fans are still not supported by Metal. Molten VK is emulating triangle fans. And you may try it and go, well, let's see how well they emulate triangle fans. Maybe my triangle fan emulation is better. Or maybe I'm just not going to use triangle fans. That code path works fine without triangle fans. And it's up to you to decide that. And that's an example of something every developer does when they're doing, all the way back to the OpenGL days, before that. What can the hardware do? How do I get the most out of the hardware? And that's really what this extension is about. We already have the capability on Windows to check the hardware, see what it features. On Mac OS, we have the same capability. We just need to add a few more flags for the Mac OS. So it's not really a huge subset. I'm kind of preaching a little here, I know, but it's not really a huge subset of Vulkan that we have available to us on Apple platforms. So just like the regular physical device features too, if you want one of these capabilities, you have to turn them on. They're not on by default. Just because I say I expose triangle fans, it doesn't necessarily mean you're going to get triangle fans unless you set that flag and you pass that same structure. Oops, back up. You pass that same structure down when you call create device. I guess I should stand over here by the microphone, shouldn't I? Okay. Anything else I want to add? Okay, so that's the long and short of it. That's how we package things on Mac OS. It's how we tell our instance that we want Molten VK. It's how we look in our nice portable code that we want to run everywhere. We can just say, you can have pound define Mac all over the place, but it's much nicer to go, do you have triangle fans or do you have wide lines? That sort of thing. What about iOS? Here's some new stuff. So as of the last SDK, released in January, the loader and layers are working on iOS. Only explicit layers, though. You do not have access to anything on an iOS device other than what you put in your bundle. And Apple's very picky about what you put in your bundle. So you can put the loader and the layers in the bundle for development on your machine, next to your machine, and you can run validation and you can run API dump or anything else, or simulate shader objects and so forth on your device. But you can't ship dynamic libraries for the iOS App Store. I'm actually getting a little bit ahead of myself on that. But this is what we have now is really great for development. The layers have to go in the bundle, and then if you want to use them, you have to also you have to write code to enable the layer. I'll show you what that looks like in a minute. It's exactly the same code as it is on Windows or anywhere else to enable the layer. We've already talked about where the layers go. Other than that, you don't have to worry about it. There's no VK config for devices. I love VK config. It's probably my favorite tool at LunarG, but I can't VK config my layers on iOS. For that, we have to use either the layer settings text file, which is sort of like banging rocks together compared to the new extension layer settings, the new layer settings extension that we have. And I'll give you a little bit of a lowdown to that in a minute. Validation layer goes to standard out. Here's a good question. How many of you doing Apple development are not using Xcode? What are you using? CMake? Okay. How do you debug?
Painfully with LLDB.
Okay. Okay, that's what I expected. All right. All right. I'm going to confess I'm coming along kicking and screaming to the CMake world. Xcode's great, sort of, mostly, kind of. Yeah, I was curious what the rest of the audience was doing on that. So I'm doing some market research here, by the way.
But CMake can generate Xcode projects.
What's that?
But CMake can generate Xcode projects.
Yes, CMake can. Yes, I'm going to mention that in a minute. What were you going to say? Oh, VS Code. There's a lot of VS Coders at LunarG that swear by it. Yeah, the VS Code is also very popular. I just, my own personal Xcode, it's a really great debugging environment. Anyway. Yeah, so when I debug in Xcode, I can step through my code and I'll get validation output right inside Xcode. So I don't have to run it, I don't have to launch the app from, VK config. I can do that on the Mac, and I can do it on iOS. By the way, I don't know why I missed it, but you can now debug an iOS app without a tether. It'll do it wirelessly. I think that's super cool. But you can step through the code and you'll get validation output right in the Xcode console. It's really nice. And as I was saying, the iOS App Store, no naked DLLs, it has to be in a framework. And not just any framework, there's also rules about how the framework is structured. We do plan to update that in the next SDK. We're also going to have improved CMake support. I'm not doing that. I'm sort of borrowing. Steve Winston is helping out with that. Actually, the Vulkan Samples group is working on getting the Vulkan samples working on iOS as well with the SDK. And they're kind of donating some expertise there. For me, especially if you run find Vulkan, it finds the desktop Vulkan loader and all of that. So we need to we need a special way to say I want you to find Vulkan, but I want you to do the iOS version, and that probably will be in the next SDK release. That is probably the chief purpose of my life when I get home from this event. So how do you turn on an explicit layer in code if you've never seen it? Because frankly, I saw this code 5 years ago and I glossed over it and I didn't care. Vulkan Configurator does this for me on the desktop, and I've never needed to enable a layer in code. So it's not very hard, as it turns out. You just make an array of the layers that you want to enable, and you just set the count and the in your create instance structure. Then when you call create instance, it will do it. Check the return to that and make sure it's not layer not present. That's an error. That is not a warning. If you write code that is looking for a layer and then your release process just strips the layer out and you leave this code in, then on startup, it's going to, I can't create an instance because you told me you needed this layer. Remember, Vulkan is a very explicit API. If you tell it you need a layer, it's going to assume you need the layer. So you will pound to find this away in your release builds, not for your debug builds. This is the new layer settings extension. Is Christoph here? Christoph he gets big kudos. He'll be talking tomorrow about this extension. And this is the best I could do to take his sample and squeeze it down into one slide. It's basically, you have a special structure and you give it an array of settings, and each layer will advertise what its settings are. And then you put that in the PNX chain when you create your instance, and it says, oh, this layer is being loaded, and here's the settings for this layer. And you can have your code do that. You could even do something really cool and have like some kind of, do an I'm GUI front end on your, developer mode to set layer settings for your game, and it'll all run on iOS. It'll also work on the desktop. On the desktop, I just use VK config. But on iOS, this might be pretty nice for you. So, okay, a little fast. Molten VK is just a layered Vulkan implementation. There are many layered implementations going back and forth. You have to work around missing features and extensions just like you would any other platform. There are really two schools of thought. When it comes to game development, it's like we want to run on the latest, greatest hardware everywhere, and you have to have, extensions that were just released yesterday in order to run the game. And then I actually did some casual games a while back. Very different mindset. Casual games need to run on every freaking thing, and you do not want people downloading new drivers. Hardcore gamers are used to that. I also did some astronomy software. Listen, astronomers, like amateur astronomers, they don't even know what a graphics card is or a GPU or where to find a driver. Stuff has to work everywhere. So there is that mindset that I want my thing to run everywhere. You're going to use a smaller subset of Vulkan, and you're going to use features like we just presented here to work around things or make sure that your end users are going to get a good experience. And I can tell you, if you're an engineer and you're in a walled garden and customer support, somebody else talks to your customers, you know, you're in a good place. Because when the game doesn't work, it's your fault. It doesn't matter what they installed. I didn't do anything to my computer, and suddenly your game doesn't work. I didn't do anything. Well, yeah, I upgraded Windows, but I didn't do anything to the computer. Or installed. How can installing some other game make my game not work? I just don't believe that. It's baloney. To this day, I had a demo on an iPad. My wife, it was when the iPad first came out, and I had this demo, and I was going to a show, and I was going to show, look at our new thing on the iPad. And my wife said, this is so cool. I'm going to put some games on it. I'm like, no, I'm leaving in the morning for New York. We're giving some demos. And she's like, how is installing a game going to affect your demo? I just don't. And of course, you all know, all of you, right? You don't touch it. Anyway, how did I get off on that? I don't know. Except I'm in the wrong time zone and I've not had enough caffeine. So we have two extensions, portability extensions, to help you out with these challenges. Performance is very good. I am a cross-platform developer. I think quite a few of us at LunarG, when we're not doing LunarG things, we're writing our own things because, it's what we like to do. I think that's probably how we ended up at LunarG. But I start on the Mac, and then I move it to Windows, and then I move it to Linux. So I do all my development on the Mac, and then I port to Windows. And I think that's it works great. Works great for me. We do have loader and layer support now on iOS. It is in beta, but you will be able to ship commercial applications on the App Store on iOS very soon. It really doesn't matter for development purposes. You're not going to ship this Khronos validation layer API dump in your game. If you do, you're going to get a very stern look from somebody. But you might be interested in shader objects, which is really honestly brand new, and I doubt you're going to want to ship your shader objects game, in the next couple of weeks. But we should have that ready for you in the very near future. Try it, you'll like it. I'm biased, doesn't mean I'm wrong, just makes being right more fun. Take our developer survey, as Karen mentioned. We do pay attention to that. In fact, we even put out a public report that shows, here's what everybody said, and here's what we did this year to try to address what everybody said. So we try to be very transparent about that, and we try to be very, very responsive to developer needs in the Vulkan community. The only way we can know, because I cannot read your mind, is if you write it down in the developer survey. Also, we have free tumblers. They're really pretty, blue and yellow, blue and white. They're very nice. Come and get your free tumbler. If you got one at SIGGRAPH and you pick up another one, I won't tell you about it. It's okay. Questions?
We use a lot of Qt, the Qt framework.
Qt, the framework?
Yeah.
We use Qt for VK config, and we use the Qt installer framework for the installer. That is a funny story. I was hired to work on VK config because I had a lot of OpenGL experience, and I was kind of getting my feet wet with Vulkan at the time, but I also had a lot of Qt experience. I've used Qt since version 3.
The problem that we have is we have to patch Qt so that it can detect molten. I mean, we got to put Vulkan. It ships with its own. Qt is also a framework.
Yes. Okay. So what he's saying is it's trouble using Vulkan with Qt. I really can't say Qt. I don't know why. I just call it Qt.
I'm forcing myself to say Qt.
It's
not Qt.
So I'm going to tell you what I do, which take this or leave it. I like vanilla better than chocolate too. So you can't always trust everything I'm going to say. I build Qt from source. I do not include Vulkan support. I turn it off. And all I do is make a Q window, I give it a muddle backend, and then everything else is my Vulkan. So I do not use Q Vulkan window.
Oh, it's
Another
totally-
thing you run into is they use the Vulkan memory allocator,
Mhm.
and then my libraries are using Vulkan memory allocator, and then I'll get linker errors. So I love Qt, whatever you want to call it. I think Q Vulkan window is a pretty nice class, but I just made my own and I like it better, and that's why, because it's a little tricky. Is it using Molten VK? Is it using the library? Is it conflicting with the latest version of the memory allocator? But that's just what I do. But you might find that useful as
So
well.
there is no way to set some configuration so that when Qt creates the Vulkan, it detects, it goes to Molten instead of, there is no way to sort of do it through API or something.
No, you have to, QTs, they're going to do it their own way. And that's why I build it for source and I turn off the Vulkan support. And really, it's really easy on Windows or Linux. And on the Mac, you just tell it, you just make sure the back surface is metal supported. That's that one flag. There's one flag you set in the constructor of Q window that says, make sure you've got a metal back end. And of course, the WSI needs the metal view. But other than that, everything is just Vulkan. And my stuff runs on Qt on all platforms, Windows, Mac, Linux, and iOS. And that's what I do. I just build it build it from hand. And the iOS Qt does not have Vulkan support at all, which is fine because I didn't want it.
Thank you.
You're welcome.
I have one more
Oh,
different question.
One more.
You mentioned something about Microsoft doing a Vulkan implementation on DirectX.
Yes, I double checked this morning because I know a lot of things I'm not allowed to talk about. And I was like, I'm going to mention that. Is that like under NDA? But it's called Dozen. Microsoft has a Vulkan on top of DirectX 12 implementation, and may or may not be conformant, but from what I've heard, it runs pretty well. But I've not played with it on Windows.
Thank you.
Sure. Anybody else?
Any more questions?
I
Okay.
also know a lot about astronomy. Okay. All right. Well, thank you then.